and thanks for tuning in on the second day of BTR conference on the Eastern track. Just remember that we will have another Western track starting in 8-9 hours. So let me, Nata, would be wonderful if you introduce yourself,
Yeah.
your institution and what you are doing, and I hand it over to you. Thank you.
Okay. Thank you. So, hi everyone. Sorry, I did not send the short bio to the chat, but I just bring in this slide. So, my name is Natajorn Phuksuksakul. Now I'm just starting I just starting at this job as a lecturer at Department of Civil Engineering in Thammasat School of Engineering, Thailand. And I am also working as a research officer in QUT, Queensland University of Technology, and in Australia. So let me get back to the first page here. So this project, this study, we are working together with Professor Naveen, Professor Hart, Professor Sebastian, and Dr. Yasmin, who is my principal supervisor for my PhD. And this study, we call it a joint regret minimization-based multinomial logit, generalized order logit model for analyzing active traveler injury severity and the associated vehicle type. In overall, in briefly, we try to apply regret minimization based in safety study. So, okay, we already see this slide. Here is the background that I'm going to talk today. So first we have background outline. We have background, data description, methodology, result and discussion, and then limitation and future study. Let's start with the background of this study. So as you all know, active traveler, pedestrian or bicyclist, they are the most sustainable transport alternative that not only improving public health, but also reducing transportation emission. And as you may realize again that many governments around the world try to promote walking and cycling communities. The problem is that low safety concern for this type of road user and impediment to the which is still an impediment to the significant uptake of active traveler. So to solve this problem, car manufacturer or governments or many research try to improve active traveler safety by using ADAS feature or we call it advanced driving assistance system. For example, autonomous emergency brake, forward collision warning, lane departure warning, and also pedestrian and bicyclist detection system, and many more. What will happen if the vehicle equipped with ADAS? So as this ADAS feature is assist motorists in their driving tasks and hence leading to the reduce in the burning on driver maneuverability. So in total, it try to reduce the human error when driving and especially when crashes likely to occur, sorry. And hence, in the events of an impedant crash with active traveler, the consequence of a crash might be reduced even if a higher mass vehicle equipped with ADAS safety feature. The higher mass vehicle, as you may know, like bus, trucks, or SUV, a huge one. Okay, so now talk about empirical context just a little bit. Even though we understand that ADAS feature help reducing crash risks and also injury severity outcome. However, none of earlier study has explored the effects of both internal and external features on motor vehicles in the same set of analysis. And hence, we have insufficient evidence on those features that benefit to active traveler injury severity mechanism, leading to the wrong policy implication and hence cost ineffective roadway, ADAS feature or even roadway infrastructure that support this type of features. Okay, let's talk about methodological context. In here, I will try to go a little bit briefly. So we have normally we apply in safety study. Normally we apply random utility maximization based multinomial logic approach. This approach, the choice within this structure, the choice with the highest utility function is chosen, and hence we call it a full compensatory framework. On the other hand, A number of studies in transport science try to adopt randomly graded minimization-based multinomial logic approach. So in this structure, a pairwise comparison of alternative attribute is applied, and hence we call it a semi-compensatory framework. However, few and far between, I mean, this technique, this approach, only few and far between in safety literature, especially in discrete outcome injury severity model. A major hurdle is that the absence of alternative specific attribute of the injury severity mechanism. So without the alternative specific attribute, this randomly graded minimization base is as similar as the random utility maximization. So that is a major hurdle that very few studies apply this technique in discrete outcome injury severity model. But the injury severity model, as in this point of view, injury severity mechanism might be a joint process of another crash specific attribute. So in overall, active traveler injury severity mechanism could be a joint process of vehicle type and injury severity outcome, even though none of crash specific variables are likely to vary by injury severity alternative. It is possible that vehicle component is likely to have alternative specific variables, for example, vehicle length, height, and other features that vary by vehicle type alternatives. Okay. So a major objective of this study is to propose to examine the vehicle type component by employing randomly graded minimization-based MNL model, a multinomial logic model. So we allow semi-compensatory framework in safety study. We examine critical internal and external vehicle features on active traveler injury severity outcome. We identify vehicle type and injury severity mechanism for active traveler as two dimensions of active traveler injury severity mechanism. And also, this is the first time that regret-based approach is applied in safety study based on police-reported crash data. Now, the data description, I hope I'm making a good time. Okay, so we apply police-reported crash data for active traveler crash data from 2015 to 2020. We have a total records of 4,727 crashes, and we integrate the crash data with the Australian vehicle consumer database to extract the vehicle component, vehicle features, the ADAS feature that related to those vehicles in that appear in the crash records. In this study, we only consider single active traveler and single passenger vehicle crash because the reason is that in multiple crashes, for example, 2 vehicles or 3 vehicles, the mechanism of crash, the mechanism of active traveler injury severity is likely to be different. So we choose to study only single active traveler and single passenger vehicle crashes, and also only passenger car and sport utility vehicles are considered. These are the list of the independent variables that we have: active traveler characteristic, motorist characteristic, motor vehicle characteristics, those ADAS feature, and temporal characteristic, and roadway geometric characteristic. And these are the dependent variables in this study. So we have a joint model, right? The first one is the graded-based multinomial logic model, which will be a vehicle type component. And these 7 alternatives are those dependent variables for this component. And we have injury severity components, another alternatives. And then we have the dependent variables with 4 levels of injury severity here: minor injury, moderate injury, major injury, and fatal injury. And here are the list of those ADAS features that we can extract from the database. As you may see, adaptive cruise control, head-up display, autonomous emergency brake, and so on. And the left figure presents these ADAS feature with respect to whether it is additional feature. You have to pay extra to get this feature equipped in the vehicles, or it is a standard feature. Okay. Okay, I have a little bit methodology to present here. So as I mentioned earlier, we apply a joint randomly graded minimization-based multinomial logic model and generalized order logic model. And for the vehicle type component, we use random regret minimization based multinomial logic model, and these are the structure of the probability functions of vehicle type component. And then we join it with active traveler injury severity component, which model by generalized order logic model. And these are the likelihood, log likelihood functions of these two components, these two structure. Okay, let's talk about result. So the result for the vehicle type component, we have, I try to present it in like a very short description. So we have two row panel for this one vehicle type component. So the first row panel is in the significant variable that increase crash. And the second row panel here is the significant variable, which is likely to decrease crash. So here we can see that if small, mid-size, and large passenger vehicles equipped with autonomous emergency brake or forward collision warning, they are likely to increase crash, which is weird, but compared to micro and light passenger vehicle. So this could be attributed to the comfortness of the driver when driving in larger vehicles, and hence likely to perform some speeding behavior, and then prevent these functions to be fully operated. So rather than efficiently brake, so the higher speed may reduce in it not fully stops, so it crashed with other vehicles. Active traveler. And then you may see that the increasing weight is also increased crash, but the increasing in car clearance likely to contribute to the decreased crash. Could be perhaps contribute to the better driving vision in higher vehicles. Another important finding is that if passenger car compared to sport utility, especially mid-size or large passenger vehicles, they are more likely to be involved in active traveler crash if those passenger car equipped with reversing camera. So this could be attributed to the driver confidence level when backing their vehicles, they did not use this reversing camera, and hence resulting in crash compared to SUV, which is a little bit, not a little bit, but they have much more blind spot compared to this vehicle, and hence it may encourage driver to use reversing camera. And here are the results from injury severity component. In here again, we have two row panels. The first one will be those significant variable with temporal heterogeneity, or we call it time varying effects. And the second row panel will be significant variable with temporal homogeneity, or we call it this variable are stable through the time. Let's talk a little bit on the first row panel here. So as you can see, for example, active traveler age over 60 years old is likely to be involved in increased severity when crash with motor vehicle, and especially it is even higher in the years of 2016 and 2017 compared to the other years. And crossing the road, active traveler at fault, motorist age less than 24 or vehicle making right turn are likely to contribute to the increased severity of active traveler. Here, another important finding, we can see that the green one on the right bottom, as you can see, the AEB and FCW, or autonomous emergency brake and forward collision warning, are likely to contribute to the decreased severity outcome for active traveler when crash with motorists. Okay. So in summary of this study, summary of the results, I would say, we present the implication of random regret minimization-based approach in safety model based on police-reported crash data. We highlight the benefits of ADAS feature on active traveler safety, especially autonomous emergency brake and forward collision warning. However, a careful consideration for these features are needed, especially for passenger car, as you may see that these two, even though they are likely to decrease crash consequences, which is injury severity of active traveler, but they contribute to the higher likelihood of a crash. Okay, and we can see that increasing length, width, and ground clearance and width are likely to increase the likelihood of crash with active traveler. This should be, the ground clearance should be removed here, sorry. And here the effects of several variables are found to be varied through the time, as I mentioned in earlier slide, the first row panel. So the conclusion, the result indicate the continued efforts on the need to install automated emergency braking and forward collision warning system as standard feature for future motor vehicles, while careful consideration is needed with regards to the exterior composites of passenger vehicles. Here is the limitation and the future study. So future research direction could consider the comparison between the comparison of the performance between utility maximization based multinomial logic model and regret minimization based multinomial logic model, and also could could examine the correlation, the potential correlation between the component between the two components, the vehicle type and injury severity component, and also it should be worthwhile to incorporate the effects of unobserved heterogeneity of exogenous variables cross observation. This can be done perhaps by using random parameter model. And this is the overall of presenting this study. Thank you very much.
Thank you, Nata. Very interesting research. Awesome. So I don't see any questions in the chat box, but perhaps I can ask you this question, although you kind of touched on it, the random regret minimization, usually it applies for the attributes for the alternative specific attributes, because we basically postulate that the decision makers they're not really maximizing the utility, they're after minimizing the regret of a decision. So in terms of the accident severity, I couldn't quite understand that, what was basically the regret minimization. What was the regret term that you modeled? Could you elaborate or maybe re-explain it again? Perhaps I've missed it.
So actually, as we may know that normally we use random maximization utility functions, right? But the problem is that not the problem, but the mechanism is that the choice with the highest utility is chosen. So it but they neglect the effects of other choice. The choice with the highest utility is chosen without consider any other choice. So we try to think in another way if we can, like random regret minimization, we have the pairwise comparisons of the alternatives. So it would be worthwhile not to, neglect this comparison. So that is why we try to adopt this technique in safety study. Perhaps it should highlight some better performance in safety. Yeah.
Yes.
That is the reason we try to apply the regret.
Understood. So also you mentioned that you modeled as like a joint. So it was the accident severity as one of the choices, and the other choice was the vehicle type with different ADAS capabilities. Is that right? So you modeled it as a joint. Was it like a kind of, I don't know, copula function, or was it, what was the causation or causality? So which one, so your hypothesis was that the vehicle type and ADAS contributes to the severity of the accidents, and is that right?
Yeah. So for the regret base, right?
Yes.
Let me start a little bit here. But for the regret, for the safety side, we don't have an alternative specific attribute. So the alternative specific attribute is those variables that vary through the to the crash, but we don't have that. So we try to fit in the joint model, because the crash side, those vehicle component like the height, the weight, the ground clearance may vary.
I'm gonna be boring right now. I cannot concentrate.
Yeah, sorry. Yeah, you can was on mute. Go on.
Yeah. What did I said? The height, the ground clearance may vary through the vehicle, different vehicles. So we use the benefits of those sides to do the joint model. So it seemed like now the overall model, we have the regret side in injury severity, but not directly regret in safety.
Understand. Yes. Although I'm not really sure about that statement that in utility maximization, the comparison between alternatives are not modeled. Still, I think actually it is modeled. The way that we're thinking is just like, they're maximizing their utility, but then in the random regret, they're minimizing the regret of not choosing the other ones. But also in the utility maximization, they do this trade-off, and in the modeling, actually, we do have that, right? Um, do you agree, or maybe I'm not? Yeah, I'm not
Yeah,
quite sure.
actually, I mean, yeah, but yeah, I got your point. Yeah, and then that is why I think we should. I mean, perhaps the performance between the two structure
Need to be
need to be
tested.
conducted. Yeah,
Yes, that would be very wonderful. Yeah, that was
yeah,
actually my question. That I realized that you had it as a future studies to
yeah.
compare and see that
The
the
perform.
goodness of fit for in sample, out sample. How would it compare?
Yeah,
Perfect. Thank you, Nata, for
thank
sharing your interesting study. And I'm so glad that actually you joined us from Thailand. So please spread the word about the BTR conference. We need more presenters from Thailand. Exciting work.
thank you so much.
Thank you so much. So the next presenter, Anisha, I think Anisha is from Bangladesh. Yes. Hi, Anisha. How are you? So I hope that you're safe and your family and friends are safe back in Bangladesh. We are all, monitoring the news. Sometimes, like a few days ago, it was so relieving that the people of Bangladesh kind of won, and then I was hearing a mixed messages. So I hope that you're safe.
Can you hear me? Am I audible?
Yes, but your voice is a bit weak.
So is it better now?
It is better now. Yes.
Okay. Okay.
Or if you
Yeah,
can speak up a bit, that would be
the
wonderful.
things are still unstable, but I'm at my home. The universities are still closed. So yeah, we are trying to do our best. Yeah, things are not normal yet, but
Yeah.
we are living our everyday life. Yeah. Some of us are attending BTR as well.
Thank you so much, Anisha, for it's such a critical time for
Yeah,
joining BTR. Uh, we are actually crossing our fingers, for sooner stability
thank
in
you.
Bangladesh and freedom and democracy. So we are closely actually watching that. So Anisha will present about investigating the state of Chauffeur dependency in Dhaka. So Anisha, feel free to basically go ahead and start your screen, sharing your
Okay.
screen. Thank you.
Let me see if I can share my screen.
Yes. So please.
Can you
Yep,
see?
that's perfect. So
Yeah.
Anisha, if you could introduce yourself, also would
Sure.
be awesome. So I hand it over to you. Thank you.
Okay, thank you. Yeah, so this is actually a joint venture. I'll be presenting the work. It was mainly done at the Bangladesh University of Engineering and Technology, which is located in Dhaka, the capital city of Bangladesh. Couple of my students were involved in it, and we had couple of professors as well who supervised the project. And Professor Zia Wadud is not at BUET anymore. He is actually an associate professor at University of Leeds. He advised the project as well. And I myself is an associate professor working at BUET. I completed my PhD from QCon. Yeah, and currently I'm also an associate editor of Transportation Latest Journal. So I think that should suffice for now. So I'll move on with my presentation. At any point, I'm trying to use my video, but my bandwidth can be low. So if I'm not audible or if my voice is breaking, please don't hesitate to let me know so that I can try to do a better job.
Sure. Thank you.
Okay. So my presentation is on, this is not a very well-researched topic. I'm not trying to say that this is a very innovative thing, but this topic might not be applicable to everyone, but this is very much applicable to Dhaka. So this is basically, we are trying to investigate the state of chauffeur dependency in our capital. I think I'll directly move on to the background. Since I've mentioned that this is not a very well-researched topic, when we started on this research, I didn't find many papers on this particular topic. So I'll give you a little bit of background that we found regarding our literature review. Basically, having a chauffeur was very common during the first 3 decades of the 20th century in the US and the Europe. Whoever had car, many of them actually used to have a chauffeur as well, because car ownership was limited to very wealthy families who could offer a chauffeur at that time. But after the World War II, what happened in Europe and in the US is that car became available to the middle class people. But for them, having a chauffeur for running that car became difficult because the labor cost was high. So that's why people started to drive their own car. In most of the families, there can be some very wealthy families who can still afford a chauffeur, but it's not a very regular picture to see that the people with car is also having a chauffeur. The scenario of Bangladesh, actually, we are a developing country. So the scenario in Bangladesh actually is very different. We have one of the lowest per capita car ownership in the world. So we have only 27 private cars are registered per 1,000 people. Obviously, the number is slightly high for the capital because many of the registered cars belong to the capital city, Dhaka. However, even though the number of car is very low per 1,000 people, yet more than 2/3 of Dhaka's road remain occupied by the cars. Dhaka is one of the slowest cities in terms of traffic speed. Sometimes we say that during peak hours, the traffic speed goes below 7 km/h. So it's actually a very slow city, low car ownership, but most of Dhaka's roads remain occupied by car. And from local experience, we actually know that most of our car owners actually rely on chauffeurs for their day-to-day activities. So what happens is that since you are depending on a chauffeur, you are employing a chauffeur for 24/7, you are making many empty trips. Empty trips meaning when the car is only occupied by the chauffeur, because they are traveling from one destination of one family member to another destination of another family member. So there are mainly many empty trips. Sometimes we let the chauffeur run errands using the car when there is no one in the car. So they are going to some groceries or to some petrol pumps for the maintenance of the cars. Those things are happening as well. So that's why we just wanted to see whether this notion of us that we had, that most of the people are relying on chauffeur, those who have car, is true or not. If true, then which are these households that are most likely to rely on a chauffeur? Then we also wanted to identify the reason behind this chauffeur dependency and what type of dependencies do they actually have. So if one household say that, okay, I use chauffeur for only one travel purpose, but not for all travel purpose, then what is that most likely purpose is? These are the things that we wanted to answer. So for that, basically, we started with a structured questionnaire survey. We designed a survey where my students, Ashik is there probably. So Ashik and Shushmita, who is not here anymore, she went to USA for PhD. So these are the students who helped me designing the survey and conducting the survey. The survey was conducted in the middle of 2022. We collected data from slightly more than 300 households. And we set one simple eligibility criteria, which is that the household has to have at least one car that they use on a regular basis. The car can either be owned by the household or the car can be given by their employer for their regular use. So it's not like the car is coming to their house for their morning commute, and then once they reach the office, the car is not available to them anymore. But there are not many employers, but some of the government employers do provide car where the household can keep the car and use the car not only for the commute trips, but also for the other household errands. So those households were also eligible for this survey. So all the different type of surveys that we designed, this survey also had different sections, but we kept this survey very simple strategically. So we had a very short demographic section. So in the demographic section, our primary objective was to understand the family structure. So we asked them about the number of household members, the age of the household members, and their profession. Profession meaning how many household members are pursuing education and how many household members are actually employed in the workforce. Then obviously we asked about the household income and how many adults of the households are owning driving license. So it was a very simple one-page kind of a question. Next, we moved on to understanding the utilization of the chauffeur-driven vehicle. So a household can have a chauffeur-driven vehicle. Also, a household can have another vehicle which is primarily driven by the household member. So we kept two separate sections to understand the utilization of the chauffeur-driven vehicle as well as the utilization of the household member-driven vehicle. But for this research, I will mostly focus on this part, the utilization of the chauffeur-driven vehicle. So we basically asked them for what different purposes they use the chauffeur-driven vehicles, and we also gave them some indicators. We came up with some statements and we asked them to check mark the indicators that applies to them in terms of the reason behind their chauffeur dependency. So I'll try to give you a brief idea about the household structures that we gathered during the survey. So around 1/3 of the households didn't have any child. The households didn't have anyone less than 18 years old. Around 20% of the households had at least one child between 0 to 5 years. Around 1/4 of the households had at least one child between 6 to 12 years old, and the same proportion of households had at least one child between 13 to 18 years old. And in terms of household income, so I'm showing the income distribution in terms of Bangladeshi taka. Most of you might not be familiar with the Bangladeshi taka. So to give you an idea, we are basically $1 is equivalent to slightly more than 100 Bangladeshi taka. So if you divide these numbers by 100, that will be approximately the amount of US dollars. So only 5% of the households had an household income, monthly household income of less than 50,000 Bangladeshi taka. Most of the households actually fell in the category of 50,000 Bangladeshi taka to 3 lakh Bangladeshi taka. And then we had around 13 to 14% households whose monthly household income was more than 3 lakh Bangladeshi taka. Here again, I'm just continuing with trying to give an idea about the household structures that we gathered during the survey. So these are very simple bars I'm showing you. So the smallest value is the minimum number, the maximum value is shown at the top of the bar, and the average value is shown using the yellow dash line. So obviously, each household had at least one adult. The average number of adults in the surveyed households was around 3.5. The average number of children in the household was around 1.3, which is less than 1.5. In terms of number of members pursuing education from the household, the number was just above, the average number was just above 1. In terms of number of members pursuing employed in the workforce, the number was close to 2. And in terms of number of driving lessons, the number was again around 1.25. This number might seem high for a developing country like Bangladesh or even for the capital Dhaka, but we need to remember that the survey was conducted among the households who had at least one car for their regular use. So that's why this number is kind of on the higher side. Next, I'll move on to the 3 questions that we wanted to answer through this survey or through this study. The first question was, which households are most likely or more likely to keep chauffeurs? So basically, this is we tried to divide the households into 2 groups. And from this survey, this is the distribution we found that 50% of the households, if I'm not wrong, 162 out of the 300 households responded that they don't have any chauffeur, and another 50%, around 164 households responded that they do have a chauffeur for running their vehicles. So we decided that we will develop a very simple binary Logit model. So I think my last presenter has went into the depth of the methods a bit. I think everyone who is present here understands the workings of binary Logit model. So I will not get into the nitty-gritty of a binary Logit model. But just to give you a very simple idea, we say that the utility that a household is deriving by employing a chauffeur is coming from this equation. So that's the equation we are trying to parameterize and trying to estimate different parameters. So we have a constant, and we are parameterizing this utility in terms of different exogenous variable. I will talk about different exogenous variable in my next slide. And obviously we have an error term. because this is a random utility maximization model, and the error term was assumed to be type 1 extreme value distributed so that we have a closed form of the probability. And since most of the variables in our model were socio-demographic, that's why for the other utility, this utility actually worked as a base utility. So we didn't include any variables in this utility equation. So this had only an error term. And then the probability, we all know that for a binary Logit model, if we assume the error term to be type 1 extreme value distributed, then the probability will have a closed form. So this is the utility for the households that have a Chauffeur. So now I'd like to spend a little bit time to talk about the how or what type of variables we included in our models as the exogenous variables. So we came up with actually 5 hypotheses. So the first type of hypothesis was, this was a very simple hypothesis to come up with. We didn't have to brainstorm a lot to come up with this hypothesis. We said that, so if the household has higher household income, those households will be more likely because they will have a better affordability. So they will be more likely to employ a Chauffeur compared to the households that have low household income. The second one was in terms of the age of the household. So in terms of the age of the household, instead of using the age of the household head, which is many often which is done, or I have done that in my previous research. In this case, what we did is basically we calculated an average age using the age of the household adults. So that is a continuous variable kind of, which is the average age of the household adult members. And that's the variable we used. And we are saying that if the average age of the household is high, then those households will be more likely to employ a Chauffeur than the household which has a low average household age. So I'll talk about these things in greater detail when I talk about the results of the models. Next, the third hypothesis was the households with younger child. We thought that the households with younger child will have higher needs to rely on, will have a higher number of errands to run. So that's why these households will be more likely to have a Chauffeur than the households who don't have any younger member in the family. The fourth hypothesis was the households with higher number of people in the education or in the workforce will be more likely to have Chauffeurs. And the fifth hypothesis was the households with higher number of driving licenses will be less likely to employ Chauffeurs. So with this, I will just present
Annesha?
my days. Yes.
If you don't mind, if just for the sake of the time, if you kind of wrap it up in like 5 minutes or less, that would be wonderful. Thank you.
Yeah, sure. I'm trying to do that. Okay, so I'll just talk about how our results fall, where our results fall, whether that support our hypothesis that we had or whether it opposes the hypothesis that we had. So in terms of the first hypothesis, we got a clear indication that yes, with the increase with household income, the propensity to keep a Chauffeur in the household is increasing. In terms of the second hypothesis, this was the only continuous variable in our model. This was the only variable that was not a dummy indicator. So we use a piecewise linear formulation for this variable. And we basically found that with the increase of the average household age, the propensity of keeping a Chauffeur actually increases, or the household is deriving more and more utility by keeping a Chauffeur, but that utility starts to decrease when the household average age starts to increase beyond 55 years. And for the household where the household members are basically old, where the household age is 64 or above, the households are actually deriving this utility by keeping a Chauffeur. In terms of the child, actually, the result didn't support our hypothesis. We figured that the households with a younger family member between 0 to 5 years old are less likely to keep a Chauffeur. In terms of our fourth hypothesis that was supported, households with more members in the education or more members in the workforce are more likely to have a Chauffeur. And then the fifth hypothesis was also supported by the results. The households with more number of driving licenses were less likely to have a Chauffeur. We also calculated the marginal effect. I will not get into the details of how we calculated it, but basically what I'm presenting is the average marginal effect. And since all the variables were indicators, so it was kind of the difference between the probability when we assume the indicator to be 1 and when we assume the indicator to be 0. And then we calculated the average across all the observations. But if you have any question, I'll be happy to answer that during question answer session. So just to highlight 3 variables for which we found the highest marginal effect. In terms of income, we found that for households who have a household income of more than 5 lakh BDT, those households were 43% more likely to employ a chauffeur. Another important effect we found was for the driving licenses, the household who have two driving licenses in the households, they were 51% less likely to employ a chauffeur. Similarly, for households with 3 members pursuing education, they were 20% most likely to employ a chauffeur. Next, moving on to why do households employ chauffeurs? So the first reason we found is that for lack of parking, 84% of the participants reported that since parking is an issue in the city, there is no formal parking infrastructure in the city. Many had to keep their cars on the roads, and that's why somebody has to take care of the car while people are pursuing their errands. They are going to the hospital or for the grocery. That was the primary reason they want to keep a chauffeur. The second most important reason was found to be since many of the households have just one car and they kind of serve the needs of multiple family members using the one car. So that's why they have to keep a chauffeur. Also, for the day-to-day maintenance of the vehicles, like the tire rotation and the oil change, these things gets easier if you keep a chauffeur. And 55% of the people actually mentioned that due to the very hectic traffic situation of the city, they find it very stressful to drive. So that's why they keep a chauffeur. I think I'll skip this. The rest of the reasons were not supported by many of the participants. And the final point was what 3 purposes are served when a chauffeur is kept in the household. So in this case, we found that for 10% of the households, they use the chauffeur only for one travel purpose. And for these households, work is the purpose if they are keeping the chauffeur for only one purpose. Then for around 25% to 30% of the households, they keep chauffeur for only two travel purposes. And in that case, also work is the most predominant purpose, followed by education and discretionary. For the households that are using chauffeur for 3 purposes, it gets kind of evenly distributed between work, maintenance, and discretionary. And then for around, I think these numbers are, yeah. So this is 38% of this percentage is 38. This y-axis level is not correct. I'm sorry for that. So for around 38% of the households, they are using the chauffeur for 4 purposes, and in that case, their need actually gets evenly distributed between all the 4 purposes. So I'm not showing this bar chart for the 4 purpose anymore. So with that, I think I made it with time barely. So I'd like to conclude my presentation. It was a simple study, so I'm not going to summarize, but if I have to identify some policy contribution, I'll say that if the household members, one thing I need to mention is that due to the cultural aspect, many of the females in my country or in my city, they don't own driving license. So that's why many of the households actually keep chauffeur. Otherwise, the male counterpart need to drive their female counterpart to places. Also, many of the females remain in the house. They take their key to the schools, but since they don't have the driving license, they can't escort their kid to schools or colleges or universities using the vehicle. That's one primary reason. That's why we found that the effect of driving license was very high when calculating the marginal effect as well. So increasing the driving licenses, penetrating it among the females can decrease the propensity of keeping chauffeur in the household. Another thing, as I mentioned, 83% of the participants say that due to the lack of parking infrastructure, they had to, and I felt it personally because I can drive, even though I can drive even when I go to the hospital or when I take my key to a parking to a park, I had to keep a chauffeur because I had to leave my car on the road, and if nobody is taking care of the car, that can be stolen or that can be vandalized, so I have to keep somebody in the car. Other policy contribution are other things that all of us can think about. So I'll talk about those if anybody asks me about these aspects. Otherwise, I will stop so that I get a few minutes for the question answers. Thank you very much.
Thank you, Annesha. Thank you so much. Well, I'm kind of mindful about time because we will have 4 other presentations. So I encourage actually everyone to ask questions for Annesha in the chat box. There are a few questions already, Annesha. So I would
Yeah.
appreciate if you, yes, if you kind of reply to the
So
questions
the
later with the
yeah.
chat box. Thank
Uh,
you so much. Oh, would you like to?
oh no, yeah, I
Yeah,
can do that
yes.
later. Okay.
Perfect. Thank you so much, Annesha,
But
because
can you give me just 1 minute so that I can answer
sure,
your question?
definitely go on.
Because it's about the method. So yeah, the sigma, it would have been a sigma if I was showing the PDF, but I showed it after I take the PDF. I was showing it in terms of the exponent of the deterministic part of the utility, which is the,
Okay.
and I'm showing in 1 because if you take the exponent of 0 for the other utility, for Chauffeur non-dependency, it becomes 1. So I'm
Okay,
showing it in
great.
that form for the simplicity.
Okay,
Okay,
thank
I'll
you so
take the
much.
other questions later. Thank you.
Thank you so much, Anisha. Thanks for sharing your presentation and your research with us. Very exciting one, and I reckon very relevant for some developing countries. Okay, so the next presenter is Sabitha. So Sabitha will present a paper on analysis of importance performance perceptions of commuters in inland waterways, a case study. Sabitha, I can see that you have unmuted yourself, so please go ahead and share your screen, and would be wonderful if you also kind of briefly introduce yourself as well. Thank you.
Okay, thank you.
So I would also appreciate if you keep it to 17 minutes, so we have 3 minutes for the Q&A. Thank you.
Okay,
Yes, we can see that.
am I audible?
Yes, yes.
So I'm Dr. Sabitha Enam. I'm working as a senior scientist in water transport division of KSCST National Transportation Planning and Research Center in Kerala, India. And the topic of my presentation is analysis of importance performance perceptions of commuters in inland waterways, a case study. And my co-authors for this paper is Sanjay Kumar VS. He's the principal scientist in NATPAC, and Sherin Ennis, who was associated with this project as a project fellow working in NATPAC, and Dr. Manju VS. She's a professor in College of Engineering, Thiruvananthapuram. She acted as a mentor for this project. Now, this is the brief outline of this my presentation. Now, the introduction. Actually, this work was done in Kochi. Kochi is situated in the southernmost tip of India, in a state known as Kerala. And this city has a large network of backwaters and canals, which was used in the up to last century for transportation purpose for both men and materials, like cargo transport. But as the time passed, the more and more high-speed transportation network is developed in as roads and bridges was constructed connecting the islands. This was the backwaters and canals were now becoming less used for the purpose. But this area, this Kochi area is a tourist destination, very popular tourist destination, and it has a legacy of inland water transport. But this city is growing in a rapid pace, and rapid urbanization and increased personal vehicle usage is happening in this city, and this is causing a severe traffic congestion in this city. The transportation network existing in the city is not adequate for the use of the passengers. So promoting the inland waterways is an alternate transportation mode is a solution for this. So numerous benefits are there for using the inland waterways, like improving the quality of the quality of life of residents, reduced environmental impact, and simulating the city's economic growth, etc. So here, the State Water Transport Department is a government department of State of the Kerala, which is entrusted with providing waterborne transportation in the state of Kerala. It is the main operator of passenger transport through boats in Kochi, and there is a corporation. Kochi Corporation is also operating one route as a ferry route in Kochi. So this is a transportation scenario of existing water transport scenario in Kochi. So a comprehensive assessment of the Kochi's current water transportation system will help to identify the strength and weaknesses, and also enhancing by identifying these strength and weaknesses, we can address this and enhance the existing services. So scope of this work is limited to the identification of the factors affecting the user satisfaction of passenger boat operation in Kochi, and objectives are to identify the factors affecting the waterway operation using factor analysis to assess the importance of various factors affecting the waterway operation, and to quantify the level of satisfaction of the commuters using the passenger boats. So first of all, we conducted a detailed literature review, and as the inland waterways are not that much studied by many authors, we got some papers related to this, and we studied the factors and indicators used by many researchers, and this was taken as a guiding principle, and also we added some of these factors which are relevant to our area, that is Kochi. So here you can see that study area. The study area is situated in the southernmost tip of India, a state known as Kerala, and in the central portion of this state Kerala, this is the Kochi city is situated, and this here you can see that this city is surrounded by a number of backwaters, and also canals are also there. So these waterways can be used for transportation of passengers, and some of this area, that is Fort Kochi area, is the main tourist destinations. So this can be connected through waterways to the main Kochi city, and also there are some islands in and around this Kochi city. This can also be connected through waterways to the main island. So the State Water Transport Department is a major operator of waterways in Kerala, and SWTD operated boat routes, and also the ferry routes operated by Kochi Corporation is studied in this study. So the waterway route consists of mainly the Fort Kochi area, which is connected, and this area is a tourist destination, and through waterway 500 meter length is there, but while we are using the road, 21-kilometer road length is there to connect these two destinations, and here you can see that the fare is also given and the passenger count is also given. Ernakulam Vaipin is another route, and Ernakulam Fort Kochi is a major route here, and we can see that the passenger count is 42,000, and the waterway route we can travel this distance 3 kilometer is there, and through road 14 kilometer is there. Ernakulam Varapuzha and Ernakulam Mulavukad are the two other routes which is connecting the islands in and around the Kochi city with the Kochi. So the details of SWTD boats, this SWTD is using both steel and FRP boats, fiber boats of capacity 75 to 100 passengers, and their speed varies from 8 to 10 kilometer per hour, and about 5 number of crew is available in that boat. So this is the detail. This table gives the details of the SWTD boat operation: 3 fiber boats and 4 steel boats are used for operation, and these are the running hours and number of trips. And regarding the methodology, here the methodology used, first of all, we conducted a literature review in order to find out the factors affecting the passenger satisfaction in that area, and the data collection is conducted through a questionnaire survey. Questionnaire was prepared, and this was used among the passengers of these 5 routes of 5 waterway routes, and we conducted a survey, and the exploratory factor analysis, a preliminary data analysis was conducted in order to identify the socioeconomic factors, etc. And exploratory factor analysis was conducted. Exploratory factor analysis was conducted in order to identify the underlying factors, and confirmatory factor analysis to confirm the underlying fact, confirm this underlying factor and the relation between observed factors, and importance performance analysis was conducted in order to identify the most important factor and the least performing factor, and also suggestions and recommendations were made. This is the details of the data collection. The questionnaire survey questionnaire consists of 4 parts. First part is the social demographic characteristics like gender, marital status, education, employment, monthly income, vehicle ownership, driving license availability, and place of stay, etc. And the activity characteristics includes the location of stay, then the institute name where they are working, and the time of reaching and time of leaving the destination, and trip characteristics like trip purpose, start time, origin, destination, etc. And if they are using alternate transport mode, that also we asked. And for user satisfaction, for both importance and performance of these factors were identified, and they are prioritized using a Likert scale, or a 1 to 5 scale is used in order to prioritize this. And the number of samples to be collected were calculated using Andrew Fisher formula, and these are the number of samples we obtained. Number of samples as per the formula, 2,443 samples were collected, and after data cleaning, and only the data related to the commuters, that is the daily travelers, is used for this analysis, and 1,188 number of samples were used for this analysis. And here you can see that the results of the preliminary analysis. So here, this table shows the details of the socio-demographic characteristics like gender. 64% of these users are male, and most of the passengers are daily commuters, and in some route it varies from 44 to 75%. And work and education are the main purpose of the commuters travel purpose. And Erdogan Vipin ferry is connects Vipin to the major economic areas like Broadway, Market, etc., and also the High Court of Kerala. So this route is used by an age group of 18 to 45 working people, and their monthly income is less than 30,000 rupees. And Fort Kochi is one of the major tourist area in this location, and 29% of the passengers in this Ernakulam Fort Kochi area are using rarely. That is the mostly 20% is about our tourists. And Vipin Fort Kochi area daily commuters are 45%, and 45% of the people are using for work purpose, and 26% for personal purpose. And Ernakulam, Mulavukad, and Ernakulam Varapuzha routes are connect the distant islands with the mainland. And Ernakulam Varapuzha route, 50% of the people are students, are below 18, and 75% of the passengers are daily travelers, and their income level is very low, that is below rupees 10,000. And the Ernakulam Mulavukad route, 60% of the passengers travel daily, and there for work and education purpose. And the peak time, morning and evening peak time is also given here. That is 9 a.m. to 10 a.m. is the morning peak time, and 4 p.m. to 5 p.m. is the evening peak time. And next step is the identification of the factors. The details were collected from the boat users under 8 categories. The main categories are safety, comfort, information, service quality, service facility, connectivity and accessibility, travel cost, and travel time. And these are then subdivided into 29 subcategories. Like safety is divided into availability of life jacket, life buoys, then fire extinguisher, jetty platform protection, then comfort as seat availability, comfort of the seat, crew behavior, cleanliness, then information, detail schedule, information about the schedule, information of the signboards in the ferry terminal, announcement on arrival and departure of the boats, etc. Then service quality, like schedule of the boat, frequency, ticket counters, reliability. Then service facilities like space for luggage, ramp availability, amenities at station, vehicle parking facility. Then connectivity and accessibility, connectivity to bus stand, taxi stand, metro station, auto stand, pedestrian parking facility, etc. Then travel cost as ticket fare, parking fare, and luggage fare. And travel time, time spent in the boat, and time waiting time. These are the factors. So after identifying the factors, the EFA, exploratory factor analysis.
Sabitha, So sorry, if you can wrap up in 5 minutes, that would be wonderful. Thank you.
Okay. An EFA, that is an exploratory factor analysis, was used to identify the likely factor structure, and CFA was conducted to confirm the factor analysis. These are the details of the factor analysis. There's model indices is also calculated, and finally we got the latent factors, which is important to the, which is confirmed by CFA. These are the factors: information, service quality, service facility, connectivity and accessibility, and travel cost. These are the results obtained. And finally, an important performance analysis was conducted. The performance evaluation is conducted using an IPA technique. Here, a graphical method is used. And in the first quadrant, we will get the most important factors, which is whose performance is less. So we have to concentrate on factors coming in that area. And in the second quadrant, most important factors, but they are performing factors. And in the third quadrant, less important factors, less performing factors. And in the fourth quadrant, less important factors, but good performance. So this is the IPA chart prepared for this Kochi city. And in the first quadrant, we got the factors which is to be important, but we have to, their performance is less. So we have to prioritize these factors. We prioritize these factors obtained from the importance, performance, and data we collected from the commuters. So these are the main factors: announcement on arrival and departure of the boats, frequency, availability of ticket counters, amenities at station, vehicle parking facility, and ramp availability. And based on this study, we suggested some recommendation also. So in this study, the performance analysis of the waterway routes in Kochi city was conducted, and preliminary analysis of the collected data from each route, and we'll got an idea about the socio-demographic characteristics and peak traffic time, travel characteristics, etc. And EFA was conducted to understand the underlying structural pattern among the 29 service attributes, and CFA was conducted after EFA to confirm the latent factors, and IPA technique was used to evaluate the performance of the factors. So some of the key recommendations are: timely maintenance and upkeep of the jetty platform, including the safety measures and amenities are required, and connectivity to enhance the IPT and PT along with the improved walkability is to be provided, and proper scheduling along with the dissemination of the information on the arrival of the departure of the boats is required. So this is the references. Thank you.
Thank you, Sabitha. Interesting importance factor analysis for waterways. So for that, score the high importance factors. That was, I think, for me, it was more interesting to see actually what are those high importance factors that was found out from your survey.
So
yes, this one.
This is the entire area is divided into 4 quadrants,
Yes.
depending upon the importance and performance of these factors. And the first quadrant, it is more important factors, but the performance of these factors is less. So
yes,
you get
so these are the
factors.
areas that you have to do the
we have to improve these factors, and this section here we can see that the performance is good but the importance is less. So we can use some of these resources we are using for these factors. We can transfer into this area, that the first quadrant, so that we can improve the facilities and attract more people into this, that we can provide more facilities to people.
Exactly. I really like this slide. And yeah, so for the conclusion, I think in your paper, if you're planning to submit it anywhere, I think with the implications and interpretation of these quarters and the matrix that you got, the result would be very interesting. Thanks for sharing it with us.
Thank you.
Okay, so I'm mindful of time, and I don't see any questions in the chat box. So let's go over to the next presenter, who would be Shoufeng. So yes, we have Shoufeng with us. So Shoufeng actually will present again another interesting topic: modeling of nudging, altruism. So Shoufeng, Sabitha, if you could stop sharing, and Shoufeng, if you go ahead and sharing your slide and see if
okay, can I see it?
yes, it's popping up. Yes, please go to full screen mode and awesome. And if you introduce yourself, and also I will actually show this to you 5 minutes before your time.
Okay,
And
I
so
already use the time record.
awesome. Thank you so
Okay.
much. So Shoufeng, just introduce yourself and then you can start playing. Thanks. Over to you.
Okay. Hello, everyone. I'm So and from Nanjing Tech University, China. The title on the list is not complete. The complete title is Kinetic Modeling of Traffic Flow, Embedding Nudging Force, Social Altruism, or Full Cooperation from a microscopic to macroscopic scale. This presentation is divided into 5 parts. The first one is introduction. Okay, and vehicle automation receives more and more attention nowadays. It aims at freeing drivers from driving tasks and improve traffic safety. According to the SAE standard, it is divided into 5 levels, from level 1 to level 5. Technology advancement in vehicles promote a new traffic management approach. I summarize 3 research directions. The first one is artificial traffic fluid. It is proposed by Papazozo, and the key concepts are lane-free traffic and nudging. It aims at improving traffic efficiency. And the second one is social altruism. This concept is proposed in 1820s, 1800s, and Shoufeng initially applied this concept into vehicle automation. So it means that a vehicle can do some decision which is beneficial for other vehicles. The third one is full cooperation. So full cooperation first is used at the intersection. A buffer assignment mechanism is proposed by Lin, and also used by maneuver coordination. This concept is also used for the vehicle interaction. So these 3 directions empower autonomous vehicle with more capability or function. This paper aims to provide a theoretical derivation of how much the nudging force, social altruism, or full cooperation can improve traffic efficiency. The speed change induced by this capability or function is first derived. Then a kinetic model of speed distribution is proposed. Lastly, the corresponding hydrodynamic model is derived, and the contribution of each capability or function to average speed is quantified and compared. The second one is Boltzmann type model, including nudging force. The conventional traffic flow, it is anisotropy. It means the attached vehicle receive the stimuli from the leading vehicle. Then the yellow vehicle will do a response to the leading vehicle. So this is the anisotropy. And when a vehicle can give a nudging force to the leading vehicle, then the lead vehicle gives a response to a test vehicle. So there is also the interaction in conventional traffic flow. So for new traffic flow, it has a bidirection interaction. So it is called isotropy. the logic of speed variation and the binary interaction of algebraic traffic flow. When the speed of the rear vehicle is greater than that of the front vehicle, is it possible to overtake? Yes, then the speed of rear vehicle increases to the desired speed. No, then the rear vehicle will give a nudging force to the fourth vehicle. Then the front vehicle will do the decision. If yes, then the front vehicle increase its speed to the desired speed or a percentage of speed. These are the assumptions in this paper. One assumption is increase to the desired speed. The second assumption is increase only a percentage of its speed. Then the rear vehicle increase a percentage of speed of the front vehicle. When the front vehicle does not accept nothing, then the front vehicle remains its speed. The speed of the rear vehicle decreases to a percentage of the speed of front vehicle. According this interaction assumption, then we can give the speed interaction. So for this term, it denotes the speed after interaction. So this term is the speed before interaction. So this term is speed variation. We have a discount factor. So for this is for the leading vehicle, and for this equation is for a test vehicle. Then according to my two assumptions, the first one is accelerate to the maximum. Then we can compute the areas. That is a mathematical expectation. The parameter beta is a probability of accepting nudging. And for this, this formula is for a test vehicle. Then we input the vehicle speed variation into the Boltzmann equation. So then we can derive an equation that is about the average speed. Average speed is for the whole traffic flow. If we give the initial condition, that means at time is 0, then this is V0 is the initial value. So then we can solve the average speed. When the time is to the, okay, sorry. What? Okay, I don't know why the PPT is jump. Okay, when the time is to the infinity, then we can derive the equilibrium speed. So for this page, it is about the second assumption. And for P, it is overtaking probability. It is a function of density. In this paper, our variable is a dimensionless variable. So its value is between 0 and 1. And the mu is a parameter. And this equation reflects a relation. That means when the density increases, the overtaking probability decreases. So For equation 1 and equation 2 is derived average speed with nothing. We can compare with the average speed, no nothing. For no nothing, I refer to this reference. It is written by Towson. So when we compare these three formula, we can know that these two value is larger than this. So then from the kinetic model, we can compute the density and the speed. Then we can obtain the fundamental diagram. Also, we can obtain the flow and the density. So this is for the second assumption. Okay, in this diagram, I compare the nothing average speed and the no nothing average speed. And the vertical is a difference. So we can see that when we use the accelerating to the maximum strategy, then the average speed sometimes is lower than the average speed without nothing. But for the second assumption, a vehicle only increase the speed to a percentage of its current speed strategy. Then we can see that the difference also is larger than 0. So for this derivation, we can conclude that for autonomous vehicle, when we adopt this strategy, then the average speed always larger than the conventional traffic flow speed. And then the next one is the derivation of a Boltzmann model, including social altruism. When an ego vehicle also means a test vehicle, so it is the same. When an ego vehicle interact with the other vehicle, it has a choice of the decision. Is it possible to avoid the conflict? Yes. Then the speed of an ego vehicle increase to the desired speed. No, the driving maneuver is determined by game theory. For an ego vehicle, we give him S-view angle is alpha. For alpha angle, it has altruistic probability sin alpha. So it means an ego vehicle will do a decision that is beneficial to other vehicles with probability sin alpha. The same, I give an S-view angle gamma to the other vehicle. So this vehicle also has a altruistic probability sin gamma. Then I formulate a payoff matrix. For each vehicle, it has two decisions, yield or not yield. When it chooses to yield, then its speed will decrease by a probability, PV and PU. When a vehicle chooses not yield, then its speed will maintain the same. When two vehicles both choose not yield, for safety, their speed reduced to 0. Then for each vehicle, we can compute the mathematical expectation of speed change. For yield, for this decision, the average is this one, and choose not yield, it is this one. So then we can compute the expectation. And then we input the speed variation into the Boltzmann equation. And for simplicity, we use A to denote these terms. So we can solve this equation. Then we can compute the average speed. The equilibrium speed is this one. So A denotes this term.
Shoufeng, would it be wonderful if you can wrap up in 5 minutes? Sorry for interruption.
Okay, thank you.
Thanks.
And then we plot the diagram. The horizontal is SVO value of the other vehicle. This number denotes angle. So for when the angle increases, the probability of beneficial other vehicle is increased. So the vertical is SVO value of a test vehicle. So the color denotes the average speed. So for this, you can see for this color, the average speed is maximum. And the left diagram is for the density, small density. The right one is for the large density. So for different density, we can see that when one vehicle choose not yield, and the other vehicle choose yield, then the average speed of traffic flow is maximum. The last one is derivation of full cooperation. The full cooperation is a special case of social altruism. So that means one vehicle choose yield, and the other vehicle choose not yield. So the equilibrium speed is this one. So lastly, we obtain this table. This table compare the average speed between conventional traffic flow, nudging force, social altruism, full cooperation. The conclusion is the equilibrium speed under the nudging force is the highest, and that of the full cooperation is the second. They are both larger than the conventional traffic flow. In addition, at low density, the average speed of social altruism is lower than that of conventional traffic flow. At a high density, the average speed of social altruism is higher than that of conventional traffic flow. So our results is shown in this figure. The blue line is the average speed of traditional traffic flow, and the red one is for the traffic flow with nudging force. And for the yellow one is for the social altruism. We can see that when it is the low density, the average speed is lower than conventional traffic flow. When the density is higher, so it is higher than conventional traffic flow. So the implication is when the traffic flow is low, we don't need to give the autonomous vehicle has the social altruism capability. But when the density is higher, it is needed. Okay, that's all. Thank you.
Thank you so much, Shoufeng. Very interesting result. Actually, for the leader-follower model, it kind of revolutionized this thing, right? Because before we had like one leader vehicle that could determine the speed of the whole follower vehicle, but this nudging concept actually is it was very interesting to me.
Okay,
Okay.
thank you.
Great. Thanks, Shoufeng. So again, I'm mindful of time. So we'll have 2 more presentations, but please keep the chat box busy with your questions, your thoughts, sharing any interesting research. And Shoufeng, if you have published your paper, or if you have uploaded, I don't know, as a draft or working paper, and you
And
would like to share it with everyone,
yeah,
please feel free to upload it on the chat box. Otherwise, best of luck. Thank you, Shoufeng. So the next presenter is Siyu, I reckon. Yes, so we
Yes,
have Siyu
yeah.
who will present a paper on a jam absorption driving system based on moving jam propagation estimation. Siyu, yes, I can see that you're sharing, and also start with just a very brief introduction. Thank
Okay.
you. Over to you.
Okay. Yeah. Hello everyone. Can you see my first?
Yes.
I'm Siyu Li, PhD candidate at University of Tokyo, and my research interest is in the traffic control using kinetic and automatic vehicles. And so today's my topic is about my research results on it. And my topic is jam-absorption driving system based on moving jam propagation estimation. And I would like to firstly introduce the research background. And moving jams is kind of serious issues in traffic. They usually start from traffic oscillations, which frequently occur near the bottlenecks or even anywhere. This kind of oscillations tend to form moving jams and propagate upstream. And moving jams usually occur recurrently, and they, according to the literature, they cause many adverse effects to traffic, such as increased crash risks. And researchers have developed the traffic control strategies to alleviate such moving jams, such as famous variable speed limit and ramp metering have been proposed. And recent years, as the progress of the kinetic and automated vehicles technologies, CAV technologies, more and more researchers have been interested in using the CAVs as actuators to manage traffic flows. Some famous strategies such as adaptive cruise control, ACC, green driving, flow stoppers, and also jam driving have been proposed. With appropriate sensors, controllers, and communication devices, the CAVs can perform accurate and reliable control according to the literature. And jam-absorption driving, JAD, is kind of typical CAV-based strategies. Specifically, the JAD maneuvers CAVs named absorbing cars in traffic to decelerate, to enlarge the inter-vehicle distance between the proceeding cars and itself, to avoid caught by the downstream jams and first prevent the development of the traffic jams. There's two critical actions. The first one is slow in. During slow in, the absorbing cars decelerates to enlarge the inter-vehicle distance and keep a low speed to approaching the downstream jams while avoiding caught by the downstream jams and getting close to it. And finally, when the downstream jam dissipates by itself completely, the absorbing car switch to the second action, fast out, to accelerate to its desired speed to merge into the downstream traffic. So we may see more clear about the mechanisms on the spatial temporal diagrams. So if without JD, we can see that moving jams propagate upstrings. With JD, the propagation of the moving jams have been prevented by the slow-in actions. In addition, we can see that the absorbing cars drive towards a specific point during slow-in. That is the absorbing end. That is called the absorbing endpoint, which is the jam exiting point of the absorbing car if JAD is not performed. However, there are still some limitations of the pre-studies. Firstly, the pre-studies didn't propose an operational systems to implement JAD. So why is an operational system is needed? The first reason is that real-time traffic information is needed for determining and addressing the accurate control speed for JAD. And more, the second reason is that human driver, we can also send some speed informations to human drivers to implement JAD. However, they are not so as reliable as automated systems. They may fail to follow the accurate control speeds. And more, the previous studies, the second limitation, the previous studies ideally assumed 100% control using well-calibrated determined traffic models. But if a miscalibrations happens or some kind of traffic stochastics, these factors may cause control values. So there's two typical examples of the control values for JAD. The left one is underestimation of the absorbing endpoints, and the right one is overestimation of the absorbing endpoints. And this kind of control values may cause the control performance deterioration or even worsen the traffic flow. And more, if use traffic models, it must predict the traffic states or trajectories, and this may require large amounts to save, store, or transmission this kind of data. And therefore, in our studies aims to have designed practical operational systems to implement JAD, and also developed moving jam propagation estimation in place of using traffic evolution models. And in the next session, I would like to explain the methodologies. So this is our study is simulation-based studies. So I would like to firstly introduce the simulation framework. The simulation generates the virtual traffic by using car-void models and use this moving jam estimation approach to predict the absorbing endpoints to perform JAD in the simulation. And then I would like to introduce the system framework I have developed. The systems use the camera sensors to detect the real-time vehicle trajectories. And then the central controllers select the series within the traffic to perform JAD. And the JAD can be performed by two kinds of JAD strategies. And the first one is called complete JAD, which is absorb the moving jams one by one. And the second one is called the synergetic JAD. It can simultaneously absorb multiple moving jams. And also in the control framework, there are two main modules. The first one is moving jam estimator, and the second one is the JAD controller. And in the moving jam estimator, the systems detect employs the roadside cameras to detect the trajectories. And when vehicles goes through moving jams, it decelerates when enters the jam and accelerates when exits the jam. The system detects this kind of jam entering, exiting points on the trajectories, and then identify the moving jam propagation. And the estimator consider 4 cases of the moving jam propagation. And the first one is the simple generation from a moving jam k+1 or the disappear at the moving jam of the moving jam k. And the second one is identify the moving jam k keep propagation. And in addition, in some cases, maybe the 2 moving jams collide each other, and the moving jam estimator identify the collisions and also the collision times. So to identify if this kind of moving jam can be absorbed by the absorbing car. And the last one is the shrinkage case. In some cases, the moving jam may shrink, and the estimators identified the moving jam shrinkage and which is the time it disappears. And the moving jam in the second module, the JD controllers decide how to select the suitable series to absorb moving jams based on the relationship, the position relationship among the moving jam and series. And the JD controller consider 5 scenarios of the position relationship to make a strategy decisions. And the first case scenario is there's a new moving jams appeared between the activities CAV, the absorbing car, and the farthest moving jam, and it can perform the synergy JD. And the second scenario is there's a new moving jam and inactive with CD, a CAV appears downstream of the active absorbing car and its farthest target moving jam, and it can perform the complete JD with the inactivated CAV. And the third scenario is there's a new moving jams appear downstream of the absorbing car and its target moving jam, and it can perform the synergy JD by the activated CAV. And the last 2 scenarios about the complete JD. And this is the flow chart of the decision making. And the next step is finally the final step is the absorbing endpoint predictions. So after identify the moving jams propagation, so we can get the shock waves speed using the linear squared, because the empirical study demonstrate the shock wave is approximately a straight lines. So the system estimate the this kind of entering and or exiting points to gain these shock waves lines, and then the absorbing endpoint can be calculated by calculating the offset of the time and space to gain these absorbing endpoints. And in the next section, I would like to show the simulation results. In the simulation, I set a speed limit zone to create a hypothetic bottleneck to generate a series of multiple moving jams. The HDV cars, the HDVs are modeled by the SSAM car frame model, and inactivated series is modeled by the determined IDM+4 car frame model. And the sensitivity analysis was conducted using this kind of effective measures, such as the driving comfort using the speed standard deviation, and fuel saving using the SID fuel consumption model, and safety improvements using the ITTC index, And the jam population reflects the time proportions of the vehicles inside the moving jams to the totally simulation time. And here's the spatial temporal diagrams results with the 0%, 5%, and 15% CAVs. It can show that these systems successfully select CAVs to perform JAD, to absorb these multiple moving jams. And the sensitivity analysis on the CAV penetration rates, NPR, also conducted. And the results shows that the JD system is able to improve the traffic performance in all the evaluation measures. And the improvements increase as the CAV NPRs increases, and about 5 to 10% CAV NPR have a significant improvement. And finally, I would like to give conclusions and future works of this study. In conclusions, we have developed a JD system using moving jam estimation approach to reduce moving jams. And this moving jam estimation approach doesn't rely on the well-calibrated traffic models. It based on the real-time shockwave speed estimation using the least square method. And the results demonstrate that low CAV NPR, about 5 to 10%, is substantially to reduce moving jams. And about the future work, we would like to consider more realistic conditions, such as the partial coverage of the camera sensors or the V2I communications, or the communication or the detection errors, or and even to the multiple lane conditions. And this is my presentation. Thank you for attention.
Thank you, Siyu, for sharing your interesting research with us.
Yeah.
I have a couple of questions, but I can actually ask those questions in the chat box.
Okay.
Yeah, I would actually like to hand it over to our next presenter. So I can see that we have Lynette and Sanjana. Lynette, not sure.
I'll say on the chat box.
Thank you so much. Yes, I will post it. I haven't texted yet.
Okay, thank you.
Yes, I will post my questions. Thank you. So Lynette, I'm wondering.
Hello.
Oh,
I'm
Sanjana, we have Sanjana. Okay, hi Sanjana.
Hello.
Thank you so much for so you can you're sharing, and please go to the full screen mode. So you're the last presenter, and we have 20 minutes. So thank you so much, Sanjana and Lynette, for sharing your research. Please just give a brief introduction about yourself and about your topic. I hand it over to you. Thank you.
Okay, thank you. So firstly, I would like to thank the organizers for giving me the opportunity to present regarding our research today. So I'll be talking on the topic of road material stock and circularity potential in growing cities, the case of Singapore. So on this research, I've been supervised by Professor Lynette, who's currently a chair and professor of sustainable transport at the University of Sunshine Coast. Just to give a quick background about myself, I'm currently working as a senior researcher at the Singapore University of Technology and Design, where my primary research is focused on urban metabolism projects, where we are trying to assess what are the material stock and flows that are coming from the built environment. And within this, we are specifically looking at the buildings and transport system, trying to understand what are the operational emissions and embodied emissions coming from these systems, both at a district or a neighborhood level, as well as the entire city level. Prior to this, I was also working in the space of electric mobility at the World Resources Institute India. And in terms of education, I've been trained as an urban and transport planner from San Jose State University. So coming to today's topic of discussion, currently, as we know that there's been rapid urbanization and population growth happening across regions globally, and this has led to a vast amount of requirement for materials and resources. to be able to cater to infrastructure and services that these population requires. So this relates to the concept of urban metabolism, where materials and resources are extracted, they are consumed and processed into infrastructure and services, and are discarded into the environment as waste or emissions. The level of resource use determines the magnitude of final waste and emissions released into the environment. And when we look at this report by the UN Environment Programme, over the past 50 years, our consumption of Earth's resources has tripled. And going forward, when we look at this global extraction for raw materials is expected to increase by 60% by 2060. Therefore, we need to transition and think about how we can shift from those conventional linear processes of urban systems into networked and cyclical processes, that is the circular economy approach. And for this, there are certain examples in terms of design or policy measures that are being adopted. And within the building sector, these include creating compact neighborhoods with buildings that are smarter, utilizing recycled building components. This leads to reduction of raw materials by 25% and save 30% of energy needed. And in terms of transport sector, shifting to mobility that is shared and active transport would also reduce material stock requirements by 50%. That is the need for designing or constructing more in road infrastructure. It would also lead to further energy demands by 50% as well as GHG emissions by 60%. As we talked about how the built environment is utilizing a lot of resources, and this is creating certain environmental impacts leading to more GHG emissions. When we look at the overall built environment, the buildings, transport, and energy systems contribute to more than 55% of GHG emissions. And when we focus more into the transport sector, around 30 to 50% of the material stocks are constituted by transport infrastructure. In terms of the land transport, for every 1 kilometer of paved road network, the materials are extracted from the Earth's resources, which is a finite resource. And when we look at the global example, around 1 billion tons of crude oil is processed into bitumen to construct roads every year. And more than 300 billion tons of material is accumulated in the global mobility infrastructure, with majority of them in road infrastructure. And this is contributing to more than 8 gigatons of CO2 equivalent GHG emissions. The conversation so far has focused on reducing operational emissions with recent examples of that we are seeing in terms of development of electric mobility in order to reduce operational emissions coming from the usage of IC vehicles. However, the conversation on reducing the embodied emissions from construction materials and processes still remains rare. This has mostly focused in the building sector, but in transport, it still needs more discussion and research. Therefore, to fill this gap, we through this research, we are trying to understand by quantifying what are the material stocks and flows that the transport infrastructure accumulates, how much of the materials are generated as waste, and what is the potential for utilizing these materials back into the road construction sector. So this gives policymakers and decision makers the idea to redefine or realign their policy measures in order to have more circular loop systems. Therefore, our study aims to investigate the material stock and flow dynamics within Singapore's transport infrastructure. In terms of research questions, we are trying to understand what is the magnitude and composition of material stock within the road network and how it varies across different road categories. In terms of annual requirements, what are the material flows required to accommodate the expansion of the road network, and what are the flows of recycled materials as well as waste generated, and how does the material stock relate to the transport services provided in the city, as well as we try to also understand what is the potential for circularity in Singapore in terms of reusing the waste materials within the construction sector. So when we look at the Singapore's transport system, the city has not only focused on building infrastructure to support private vehicles, but they've also built infrastructure to support other modes such as urban rail network, cycling paths, as well as pedestrian networks. City has also focused on developing underground infrastructure with components of urban rail network, expressways, as well as pedestrian networks that are running underground. And when we look at the past record of expansion of the road network and compare it with the population growth, as population growth has been increasing, the road network has also been expanding in Singapore. On an average, the annual growth rate of road network between 1990 to 2022 is around 1%. Since we've talked about the road infrastructure, now we specifically focus on the road pavement. Like any other older settlements, Singapore was also, the roads in Singapore were also constructed using laterite, which is a reddish soil in the 19th century. But with growing motor vehicle traffic volumes and the heavy loads that run on these road network, these networks have been replaced with asphalt surfaces. And most public roads in the city are flexible pavement, that is also called as asphalt mix pavement. But in other parts where there's heavy traffic loads, such as intersections, bus bays, or even ports, this require rigid and semi-rigid pavement, which is a concrete mix with reinforcing steel mesh. But more than 95% of the pavement structure in Singapore is flexible pavement. So now that we know what type of payment structure we are focusing on, now we try to understand what goes beneath these payment structures, what are the different layers, and what are the materials that these layers is composed of. A typical asphalt road is made up of 95% aggregates and 5% bitumen, which is used to bind this together. When we look at the layers, the top two layers, that is the asphaltic wearing course and base course, is comprised of bitumen and aggregates, whereas the other layers, that is the base course and sub-base course, is mostly aggregates. And in terms of the materials, the traditional materials that are used include bitumen and granite aggregates. But in Singapore, there are other materials, that is recycled or waste materials, that are also being utilized in the road construction industry. So in terms of the materials, the first one is the steel slag, which is a byproduct from the steel production industry. It is generally reused and in the upper layer of roads. In our study, we've assumed that 30% of the expressways utilize steel slag aggregates in place of granite aggregates. The other material is milled waste, which is asphalt that has been machine milled from the existing roads during the maintenance activity. And this is also recycled and reused as sub-base material in new road construction. Recycled concrete aggregates, which come from the construction and demolition waste, are also utilized within the sub-base layer. Apart from these materials, Singapore is also exploring alternative materials, including waste plastic and material generated from incineration bottom ash. Currently, there are ongoing trials happening on certain road networks. Coming to the methodological framework that we've adopted in our study, so we applied a bottom-up approach where we've estimated material stocks and flows considering the road network inventory. And in terms of the inflows, we focused on understanding what is the material required for new construction and maintenance every year. The material stock is the accumulation of materials over the past years. And in terms of outflows, we look at what are the materials that are generated as waste and how much of it is also being recycled. In terms of the research scope, we've focused only on 4 road categories, that is the expressways, arterial roads, primary access, and local access. And in terms of material types, we look at bitumen, steel slag aggregate, and granite aggregate. And then we try to estimate what are the embodied emissions from these materials. In terms of the components, infrastructure components, we've not considered certain components such as the rail-based infrastructure, airport runways, and other facilities, including tunnel, bridges, and overhead pedestrian crossings. We've also focused our research to look at only the asphalt pavement, and we've not looked into the rigid pavement structures. So looking at the data parameters and the assumptions that we've considered, there are basically 3 main data variables, that is the material intensity, schedule maintenance intervals, and share of recycled materials. The first one helps us quantify the amount of material that is needed in constructing a unit area of road. And this is estimated on a per material basis, considering factors such as what is the thickness of layers, including the width, the void content that is allowed, and also the density of these materials. The next one is the maintenance interval. For our study, we've considered, we've assumed certain maintenance interval as per the different road categories from the literature. However, in reality, the maintenance, the frequency of the maintenance would even be higher, because considering the repairs that might be required, considering the weather conditions or any other factors. And in addition to that, we've also looked at the share of recycled materials. So whatever materials are removed from the upper layer during the maintenance activity are reused again into the different layers, and this is governed by technical limitations or the local government standards. In Singapore, 100% of asphalt is recycled, but as per the local standards, only 20 and 30% of reclaimed asphalt limit can be used. Therefore, we've assumed that whatever materials that are being recovered, only 30% of them is being utilized again in the road construction. Next, we try to compare the findings of Singapore's material intensity values with other countries as well as cities. The top, the highest values are observed in expressways and arterial roads as compared to primary access and local access road. This is because obviously the thickness of these layers is high as compared to other roads, as well as the traffic volumes that these road network carry is also high. And in terms of the calculations, the Singapore numbers align with the material intensity values of Japan, the global average, as well as Bangkok calculations. Next, in terms of the results, what we found that the share of granite aggregate is the highest as compared to steel slag aggregate and bitumen. And this is obvious because the share of granite aggregate in the pavement structure is approximately 95% as compared to just 5% share of bitumen. As well, when we look at the steel slag aggregate, the share of this material is also low because we've assumed only 30% of expressway road category have currently utilized it in their construction. And based on the literature, we found that the steel slag was only being used from the 1994. We also try to compare the materials stock per capita of Singapore with other cities. And when we look at Singapore, the material stock is below 10 tons per capita. And this and other cities like Tokyo, Beijing, and Hanoi fall within this range, similar to Singapore. And in the context of Singapore, it makes sense because most of these settlements or districts are compact, and a lot of these infrastructure services are shared between the resident population. Therefore, we see a lower per capita consumption here. As compared to other cities, Bangkok and Brussels fall between the 15 to 30 ton per capita range, and other regions like Vienna and Samotraki are more than 50 tons per capita. We also try to see how the material stock are distributed spatially, and for this we compared the material stock with the population density over a 1 square kilometer grid, and we found that there's a negative relation between the material stock per capita and population density. When we look at the areas with higher material stock per capita, these areas have low population density, that is less than 5,000 persons per square kilometer. And in regions with low material stock consumption per capita, these regions have high population density on a per square kilometer basis. Therefore, this indicates that as population density increases, the per capita requirement for infrastructure decreases, and more compact and dense settlements utilize infrastructure services more efficiently as compared to low density settlements. In terms of the material flows, we found that the material used for new construction is higher as compared to the materials that are needed for maintenance, because only the upper layer of the materials are replaced during the maintenance stage. And we see certain peaks like in 1994, this is because the new expressways were being built during this period. And there's no construction that happened in 2017. And in fact, the existing road lane kilometers were converted to cycling path or even pedestrian walkway. And when we look at the average material requirement on an yearly basis, it is approximately 0.5 million metric tons, which according to ChatGPT is roughly equivalent to the volume of 112 Olympic-sized swimming pools. In terms of the material outflows, we find that the amount of waste generated is higher as compared to recycled material, because we've only assumed that 30% of the materials are being that are being generated as outflows are being recycled, and this is according to the material specification standards as specified by the Land Transport Authority, as I mentioned earlier. This gives a picture on from policymakers on how they can regulate their existing standards in order to incorporate more recycled materials in the existing road construction materials, apart from just extracting more and more newer or virgin materials. Then we look at this Sankey chart, which shows us the material stocks and flows for the year 2022. And we see that the material inflow, that is material required for construction and maintenance within this year, is approximately 0.82 million metric ton. And this was extracted from like imports and local sourcing as well as the recycled material. Whereas the existing in-use stock is around 50 million metric tons. And within this, the share of arterial roads is higher as compared to local access, and then primary access roads, and then expressways. In terms of the material share composition as well, the granite aggregate is highest as compared to the other materials. In terms of the outflows, we see that after applying a recycling rate of 30%, we see that 0.11 billion metric ton of material was recycled, and the rest of it was dumped as waste. That is 0.29 million metric ton of material. And then based on this material stock, we try to estimate what is the embodied carbon by incorporating carbon emission factors of these materials. And we've sourced that data from EcoInvent database. And we found that Singapore, the road material stock constituted to around 5.23 million metric tons of, metric tons of CO2 equivalent embodied emissions. And in comparison of Singapore to other global countries, which are, of course, larger in scale, like China, United States, and India, the embodied emissions is more than 1 gigatons of CO2 equivalent. And we also try to compare our material stocks with the material efficiency and for material, in order to understand if the resources are being utilized efficiently or not. And as an indicator, we've considered vehicle kilometer traveled as a transport service indicator, where other studies also look at freight kilometer travels as well as traffic volume counts on certain road networks. The existing research also suggests that with increasing material stock, that is increasing high investments in road infrastructure, also leads to high travel intensive lifestyle that is more dependent on private vehicle transport. Whereas in the context of Singapore, we see that there's a declining trend that is observed in terms of material efficiency. And during this first period, that is 2012 to 2016, one of the reasons could also be because the private vehicle, the mode share of private vehicle transport declined from 37% to 33% between this period. And during the COVID period also, we can see that there were limitations in mobility movements. Therefore, there was a declining trend observed here. And this also suggests that even though we see that there's growing material stock accumulation in Singapore, indicating that more and more investments are being directed towards road infrastructure, it also gives a clear indicator that this infrastructure needs to be accommodated with developing infrastructure that supports other modes, including public modes or even active modes as well. So here I just wanted to conclude that in our study, we understand that there were certain components that were not included. However, for future research, the embodied carbon emissions would be interesting if it incorporates underground infrastructure as well as new infrastructure that is coming from the electric mobility in terms of charging stations or even wireless electric roads. In order to capture the carbon footprint or the environmental footprint of the entire transport sector, it would also make sense to incorporate not just operational emissions coming from the vehicles usage, but also from street infrastructure, for example, from road tunnels as well as street lighting activities. And also, since most of the material flow analysis studies are focused on at a city level or regional level, it also makes sense to carry out analysis more at a lower resolution, that is at a district level or neighborhood level. This would help us give some the different stakeholder groups in terms of designing policy measures that are more targeted interventions. And here I would like to stop and thank you for your attention.
Thank you, Sanjana. Thank you so much. Very different topic from the other topics, and it's not really my, research domain, so I can't really ask any question, to be honest. But it was interesting to me, and I'm sure that it also benefited all our audience here on the call. Okay, so I don't actually see any question here, and I'm looking and I see that we are actually 5 minutes over time, and it's just 5:05 p.m. in Australia. So kind of, the end of working hours. So I wanted to thank you all for submitting your papers to BTR, for tuning in, listening to the presentations, and also presenting. So I would like to thank Giancarlos, Lynette, who lined up, Lynette actually lined up all the headline speakers for us this year, and Giancarlos was the chair of this year BTR conference. Lots of coordination, lots of work in the background. A big shout out to Gian and Lynette, and also Yikang, our Zoom coordinator, who since yesterday and also today, he allocated his time very kindly to this presentation, to this meetings, and also set up the Zoom meetings, and very well done, Yikang. So without a further ado, I just wanted to thank you all and just remind you that if you are in a better time zone, perhaps you can also tune in to the Western sessions tonight. It's going to be 1 a.m. in Australia time, but 10 a.m. CDT time. So you can do the conversion and see if you can tune in, because there will be another headliner talk from Denmark, and it's going to be very interesting. Okay, thank you all, and please just spread the word for BTR. Let's just keep this conference going, and with stronger papers, high quality papers, and also I just wanted to again tell you that we have a special issue of Journal of Transportation Technology and Planning, TPT, published by Taylor and Francis, that we shortlist the high quality papers from BTR for this journal. So please let me know if you have one of these presentations that you presented today or yesterday. If you have not published it before, just give me a hint, and then I will look at the list and see that if we can shortlist your paper. Okay, did I miss anything, Gian, Lynette? Would you like to add?
No, everything
good.
covered. So hope to see you guys in the next video, right?
yes, next BTR next year, and we are hoping that we have actually more, paper sessions and even like more special issues in high quality journals, Q1 journals as well. So keep the BTR, in your focus, and keep tuned. Stay tuned. Thank you.
Thank you.
Bye bye.
Thank you all. Have a good day. Bye.
Bye.